Right. Hello, everyone. Welcome to another edition of our subseasonal forecast contest. For today's agenda, we'll start with attribution, look back at the past week and the past few weeks since the start of the cooling season, and then we'll get into our forecast. And we may have some extra time here today, so if anyone wants to talk about some of their research near the end of the call, we can do that too. Before we get going, does anyone have any special topics they want to make sure or that they'd like to hit today? No? All right. If anything comes up, we should have some extra time. So, all right. Let's start with attribution here. The most recent verification is from June 9th, or the mark date, June 9th, and verification or target window, June 24th to June 28th. So let's take a look. So I just sorted this by performance, CRPS. And let's start with the verification. The verification is here at the bottom. It was at 52.9. As a reference point, the 30-year is 45.8, and the 10-year is 51.7. So this was a forecast that, verified warmer than the 10 and 30-year, just a little bit warmer than the 10-year. So pretty warm forecast. And it looks like Matt Lanza was the big winner. He almost had a perfect forecast, or at least in terms of the forecast mean, at 53 and a relatively low spread. So he was rewarded for that forecast. Matt Rogers also had a nice forecast. It looks like overall, I guess, really, it's like a broken record. Like everyone did well, or pretty well, with the exception of the CFS. I swear, I think sometimes maybe we're pulling the wrong data, but I don't think we are. 40.9, the CFS at 40.9 was colder than the 30-year, and wasn't a good forecast. What can you say? It was over standard deviation, off from the verification, the standard deviation and a half. So, and the CFS, that's been a theme. We've talked about this already. I'm sure we'll talk about a little bit more today, but CFS just has had a tough time with a significant cold bias. And I think we've seen in some of our other skill metric charts from previous years that that's been a recurring theme. But again, overall, folks did well, and that's because in general, most of these forecasts were well above, or at least above, the 30-year normal. And of course, the forecast verified above the 30-year normal. So as compared to the 30-year normal, most everyone here did pretty well. Let's just take a look at the pattern here real quick. And again, this is what, June 24th, June 28th. So we'll pull up the map on this guy. And actually, before I switch over to the map, this is the same period. So, whoops, I didn't mean that. You can see it ranked, looks like it ranked about 10th since 1950. So pretty warm forecast there. And let's look at the map. Where's the map? There's the map. So really, much of the country above normal in terms of temperatures, with the exception of a pocket from Texas up through West Virginia, this little pocket here, and that means something, right? This area does put out a lot of cooling demand, right? Because these areas normally are in the 80s and 90s, and there are some population centers, Dallas, Houston, and Nashville, etc. So this is the only thing that kept us from probably being like a top 5 or even higher temperature or CDD forecast. Let's also take a look at the hemispheric, and then we'll take a look at the editor notes, and then we'll open it up for everyone. All right, that's in terms of temperature departure. Interesting, I hadn't looked at this earlier, but obviously quite warm across North America here and Europe, but there is certainly some cold pockets on the other side of the globe there. Not sure that has any significance, but for us. But anyway, here's the forecast, or here was the verification. This is kind of interesting verification from a 500 millibar height. Is that right? Am I looking at that? That's interesting. Let's zoom in on this a little bit. I guess what strikes me is being interesting or a little bit surprising is we had this kind of trough over the eastern states, right? It looks like a decent trough. I'm going to switch over to temperature here just to make sure I'm not crazy. Make sure I've got the dates right. I've got June, right? June. Right. Okay. And then that's in terms of temperature. Now I'm going to do it in terms of CDDs. Oh, you have to be over in the United States to do CDDs. Let's do this first. I find this interesting. So that's temperatures. Well, that's fine. Yeah, temperatures. So that's temperature. Now let's switch back here real quick to 500 millbar heights. Where is it? Oh, you can't do that at this. All right, so I have to switch over to North America. Let's switch over to North America. All right, now let's do 500 heights. Yeah. Does that, I mean, I would, with that kind of trough, I would have expected not quite as much heat or above normal anomalies in the eastern states. Anyone else find that a little bit unusual too, or am I the only one?
The temperature departure looks slightly different if you compare this with the US, at least the distribution of the anomalies.
I'm sorry, Philip. You were saying that you mean comparing at the 500 millibar level versus surface temperatures, or were
No,
you?
the surface temperature on this map with the North
Oh
America
yeah,
looks a little different from the CONUS.
yeah. That's a good point. Let's do that. Yeah, I'm thinking, am I crazy here? All right. So the coldest anomalies are down here in southwestern Texas, and then over in the thumb of Michigan, right? Average temperature departure. Now let's go to the United States. Did anything change? I don't think so. And there's a little gap right in western Tennessee. Yeah, that is what because we're not looking at this is still supposedly this is still temperature departures. So why would it be? Well, I guess there's some sort of they must use different data. I guess that's it. I get it emphasizes Dynacast here. I'm guessing that they use some maybe like in the projections that are looking more globally or bigger scale, they use like CFSR or something like that, like a CFS data set. But maybe for the United States only, they're actually using official, um, maybe like station data or something like that. But you're right. That's actually a decent difference,
Hey,
right?
hey, Dave.
Yeah.
I'm gonna, yeah, this is something that I really think, especially given what you're saying right now, that we should do. I think relying on the Maxar data for verification and not like model verification there's a million ways to do that incorrectly and to create situations like this. And I think it's worth it at this point for someone, maybe this would be a good project for a student, to look into the models that are the data that Maxar is giving us, to identify any inconsistencies, and we could probably find a lot of explanation for what we're seeing, and we may want to adjust that going forward, or bring those problems to their attention, because it could really be throwing us off in a big way,
Yeah.
with trying to test out our different methodologies for forecasting. One of the things I can think of immediately is if you don't have two models on the same grid, if you're comparing apples and oranges, and one is going to look terrible in comparison to the other, because of how the data is compiled together to compute the CDDs. If there could be an inconsistency stemming from that. There's other reasons I can suggest, but my guess from what you're seeing is that the verification or something's being computed differently.
Yeah. I think you're right. I think and just looking at this little thing down here, I'm pretty sure this is probably the station. Yeah, station data because
That's a
up
problem.
over it. And
I'll
this
tell
is
you right now, that's a problem.
Yeah, this is the CFSR. Or this, well, I'm not sure it's CFSR, but it's something else model. Yeah, yeah, it's
It's
interesting.
likely
Yeah.
they made those decisions to be able to put out their data in a real, their goal is to be real time.
Right,
Um,
right.
and that is forcing decisions that are impacting the quality.
Yeah, yeah, it's interesting. Yeah, we can maybe I'll try to do this after. We can at least ask them about the difference. But I think we might be right. I think it might be CFSR versus station data. It's good to know. You're right. Yeah, I think it would, be an interesting project to look into at some point. Um,
Yeah, another,
yeah,
sorry, go ahead.
go ahead.
Another thing that would be awesome to look into is just even going in and looking at the differences in the model formulations. Um, Sean, I think this might actually be a really good project for you, um, because we're starting to learn more about subseasonal models. Like, this is not ECMWF, the short range model that we're all used to using. This is actually a different model that's initialized differently. There are differences in how the coupling is done, all sorts of things that go into how good the forecast is. And my guess I've only looked briefly, but CFS, there hasn't been funding to support turning CFS into an actual subseasonal model. And you can tell that just from how it's being initialized. And there's some blatant reasons to not trust it, or why we're seeing really bad results. So that would be another step that I think would be really important to do, and give us all some insight into, how to weight our forecasts.
Cool. Yeah. So, and I guess yeah, so interesting there, the difference between the maps. And I guess one other just point on this before we move on, just the point of shallow troughs, right? Sometimes this is surprising to see this kind of pattern to me again, to see such a difference between, if I, as a meteorologist, if you told me this was going to be the 500 millibar height pattern, I would have expected a colder solution, more cold anomalies. But it's interesting how that can occur. I mean, right? I mean, that's just, I guess it'd be more time to look into this. But obviously, this was not a trough that was associated with cold anomalies, and I guess there was enough flow off the oceans and just warm southerly flow in general, and maybe impacting the min temperatures more so across the Northeast to keep temperatures up. And it. I just the other, I think, fascination with this is, we sometimes talk about how teleconnections, like, just because you have a negative NAO, it doesn't guarantee it's going to be cold, right? But there's a correlation, right? There's a correlation with this, and almost certainly there's a good correlation between troughs in the east and cool weather in the east. But this is one of those situations where kind of it fell apart, right, somewhat. And speaking of studies, again, I don't think this is a critical study, but I think it would be interesting. I'm sure folks have done this, but to look at situations, in where there's patterns where there's troughs in the east and they don't result in the sort of canonical type response. Um, so anyway, so thought about that. Um, any other thoughts about this? I'm going to switch over to the editor notes so we can look at what Radiant was talking about during this period.
Just looking at my forecast
Yeah.
too, I thought two interesting things were, apparently in my forecast I wrote ridge, trough, ridge as my pattern configuration. So it looks like the models, it must have been that something was hinting that there would be some kind of trough, but looks like maybe it was a little further east than forecast. And as for temperatures, this is more of a frustration maybe, but I noticed that the week before the verification was below the 10-year, and my forecast was warmer than the 10-year, and then for this verification, it was above the 10-year, and my forecast was lower than the 10-year. So you still can't beat the 10-year.
10 years tough. Yeah. I think we said last year it was, I think last summer it was like the best forecast. If it wasn't the best, it was right up there. So, um, yeah, it's hard to beat the sort of the trend, right? The sort of climate trend here. But it's funny what
Does
Philip.
anyone feel like maybe the 10-year is somehow involved in the verification, and like that's why it's so good?
Aren't they using 30-year for verification?
What? Yeah, like I'm dying to just sort of try and be able to reproduce their verification so I know how it's done, because there's some reason um, the 10-year is good, and it's not because it's spectacular. Um, you know, I feel like just based on everything we've seen, there's likely some reason for that.
Well, you mean beyond, like, specifically we were talking about summer, and I guess the hypothesis in the past was just simply that, you know, that the summers have been warming, generally warming, you know, in the United States, and that it's been following much closer to the 10-year than the 30-year, and that's why it's in our, you know, you think something beyond that?
Yeah, like I don't think the verification is a pure observation, and there's um, something that's the verification and the model I don't think are independent enough, and that's kind of a clue when the top performer is a climatology.
Okay. Yeah, I'm not
Um,
sure.
yeah, I mean, there's yeah, we can't say for certain, but there's that I find that kind of fishy.
So you mean like they, so you mean like they might be using climatology to smooth the data?
Something, something like that, yeah. Or it's somehow involved in that in the verification, because the verification should be an independent and from pure observation, but I'm not, since we don't know where it comes from, it's possible that things like that can leak into um, something that's thought to be a verification data set if it's not really truly a verification data set. These are the type of symptoms that come up.
To my knowledge, it is, but yeah, we can ask them. You know, we can always ask them after the
I think
call.
I have, and we don't really get a satisfying answer. Probably the approach is to try and reproduce it. That's my guess. Because we should know how, you know, we should be able to reproduce any verification and know how the CDDs are being calculated.
Well, yeah, but I think it's a little challenging, and the reason, you know, of course, we're very grateful for Maxar for providing all
Oh
this
no,
data.
yeah, it's
Well,
not to
well,
like, I'm not.
well, I just want to make the point that they use a number of stations, right? There's it's hundreds, at least hundreds of stations that go into the CDD calculation, and of course they have it's like a population weighting, right, scheme, and you know, and that's applied to each of the stations and stuff like that. So um, it
Right, so
is.
station data is misaligned with verifying a model, right? So um, like that, they're not a straight comparison, and we know they're from station data. There's just from that being a point source, that creates an incredible amount of bias in the data that is not reflected when you're trying to verify a model, which is an area average.
Right, but you know, and we're sort of getting off track a little bit here, but for the purpose of this, right, we're trying to reproduce what happens in industry, right? In industry, at the end of the day, what the energy traders care and the commodity traders care about is, was it 95 in New York City, right? That's because
Uh-huh.
that's what's going to blow the load. So at the end of the day, it's, you know, it's the meteorologist's job who's at these companies and stuff to try to predict as best they can what, you know, New
Mm-hmm.
York City is going to be in the CDDs. So in this case, we're not we want to know model biases, but we want to know model biases ultimately so we can get the best CDD forecasts for the United States, because that's what that's the goal of the contest. And yeah, so there's, you know, there's a little
Okay.
bit. a little bit different.
Yeah, no, I understand your point. But in terms of and I totally get that, but in terms of being able to improve ourselves and improve our forecast and test methodologies, which is also the point of this, you want to have a verification data set that is truly matched. That's just the thing we want to be ensure without, obviously, without, have no intention of insulting Maxar or being, trying to oust them for anything. But it's something that would be important to us that maybe isn't important as much to their customers.
Yeah, it'd be great. Yeah, I agree. It'd be very helpful. Okay, let's see. Looking at Maxar, speaking of Maxar, so this was, no, this is today's. I don't want today's. We're still on attribution. We'll get off attribution here in a second. But this is the forecast from June 9th, right? Verifying for June 24th to June 28th. So actually, their forecast, starting with Maxar, this is the eyeball test. That's nothing more than the eyeball test, no spatial correlation. But to me, it looks, ridge trough. Obviously, the trough actually dug a little bit down more into the southeast or south central, and there was warm over the top. But I guess the general flavor was there. Their number was, pretty good. We talked about this earlier. The CFS was the only number that was really bad. The CMWF was in the ballpark, very, very much in the ballpark. It was very close, actually. And looking at the spatial patterns real quick, the Steve Bennett eye test. The EC, kind of looks very close to Maxar, and that's, I guess, a good thing. In the CFS, it's interesting here. The CS, it's just kind of, it doesn't look terrible at all, but obviously at the surface, these just not enough warm anomalies, right? Just not enough warmth is the bottom line. Is, I guess, in particular across some of the western states and whatnot. Right. Oh, I know what I was going to say. Just one other quick thing about spatial patterns. I was going to say when Philip, it's often we talk about. I think with Dr. Decker, we've talked about this a little bit. How sometimes you can be penalized pretty harshly for getting the spatial pattern wrong because we have such big population areas in the eastern half of the country. So in other words, I think the trough is going to hang back toward Minnesota and Wisconsin, kind of like this map here. But then it ends up verifying, a couple hundred miles to the east, and all of a sudden the Northeast is cool. And then, you kind of blow your forecast, even though maybe from a spatial pattern standpoint, your errors weren't that big. It's just that those errors occurred in areas which were very sensitive to even slight changes. Well, that didn't really hold up this time. Like the actual pattern from a 500 millibar height pattern, anyway, it looked like it did kind of shift a little bit to the east. But again, it was sort of a hollow trough or whatever the heck you want to call it. Whereas at the surface, there was still a lot of warmth. So I don't know what to make out of that, again, without studying it more, but I just think it was interesting. All right, I guess we can move on to the forecast. We can't avoid it forever. All right, so let's look at June 30th here. Let's see what we've got. Let's look at the range here first, and I'll turn over. I guess I was at the top, or the warmest, a little bit of a fudge factor for sure, at 72, and then the coldest. I guess the coldest is actually the 30-year normal. So everyone is definitely thinking, well, everyone who forecasted here is absolutely on the warm train. And actually, before I turn this over to folks, I cheated a little bit. This is not cheating, but just in case I bring this up, I'll share what I've seen. This is we call this sometimes the strip, the 15-day strip, looking at the next 15 days, starting with today, going out to July 14th. And I think I won't go through all this. I think you guys are pretty familiar, but the yellows and reds suggest that it's above the 30-year. And I'm looking at actually, let me switch. I'm going to look at the EC ensemble model, and I just want to give some perspective here. So the most recent full run was the 0Z, which is here. The Maxar comparison is always on the left. And just to give you a sense of how warm these forecasts are, or how anomalously warm to be more precise, um, when I look at the next 5 days, it's showing 58, and the normal, the 30-year normals here is about 49. All right, so that's what, about 8 above. The 6 to 10, 67 versus 52. What's that? About 15 above. And the 11 to 15 is almost what, 73. So almost 20, if I'm doing the math here, almost 20 CDDs above the 30-year just for this 5 day period, just for this 11 to 15 day period. So I'm not going to look at where that stands in terms of historicals, but I'm guessing if these forecasts verified, they would be, easily in the top, especially the 11 to 15, would be easily a top 5 event, maybe a top 3 or 2 event. So at least coming into the 16 to 20, I guess you can see why some of these forecasts, are so warm. Now, maybe we're setting ourselves up for failure, whatever. Maybe that's a good lead into our forecast here. So, who wants to kick us off? Who wants to talk about their forecast?
Uh, Before we do the forecast, I
Yeah,
have a question for your forecast.
yeah,
So, given that our previous, I guess this has been a while since we haven't really looked at the persistence, but at least based on our different metrics, it appears that persistence does not do very well. So, how would you explain that in light of the fact that it seems like, especially, I remember last week was also a factor, and this week it seems like the persistence effect would suggest to go higher than a lot of our forecasts. But then we also know persistence hasn't done all that well. So, what would you say about that?
yeah. That's fair. So I guess I'll go into my methodology first. I think that's basically what Philip's asking, and I kind of gave a hint as to one of the factors. So as a but to Philip's question, as a general rule, I agree. I don't think persistence alone. I think some of our studies have shown it is not a reliable forecast. So I'm not just looking at it in terms of persistence, and specifically our persistence input is based on what's occurred, right? It doesn't know the 1 to 5, 6, 10, 11 to 15. So those are a little bit of different, it's not quite apples and oranges, but it's a little bit different. I always thought it'd be cool to have an adjusted persistence factor that also includes the 1 to 5, 6, 10, 11 to 15. That's another story for another time. So basically, where do I get my 6 CDD fudge factor? I guess, again, and it's fudge. So let's start there, right? I don't have hard evidence, but I felt, I guess, like a combination of things. I looked at the 1 to 5, 6. I looked at where we've been, and kind of leading into day 0, right? And it's been getting warmer, obviously a little bit warmer than the most recent verification one was obviously a little bit warmer than the 10-year. Then I looked at, in particular, in the short term, right, the 1 to 5, 6, 10, where you have relatively high confidence, right? And obviously that's a warm pattern. And I looked at the patterns too. 11 to 15, very warm, and extreme, like these anomalies, almost 20 CDDs above, the 30-year normal. Then I also looked at the 16 to 20, and I felt like, and then my interpretation there was there's good stability in that, or the models were just showing a continuation. Then I also looked at the tropical force in the MJO, and I felt like this was there last week too. And it looked to me, I'm not going to pull it up, but just for time, but it looked to me like the MJO tropical forcing was also kind of stuck in phases 1, 2, and 3. It's kind of like locking in. So I felt like some of this is experiential. Just we're kind of getting into that late June, early July, where I do think if you are in a pattern, because at this time of year, synoptic forcing on the pattern starts to, I think, weaken. In other words, if you're in a strong, stable pattern coming into July, it takes some really strong external forces to kind of diverge from that, right? You're not in winter where there's, I think, stronger force mechanisms. So when I boil that all down, it looked to me like, I believe the pattern that's setting up over the next 2 weeks. B, I believe it's likely to continue. And I didn't want to go full in 15 to 20 CDDs above the 30-year. That would have gotten me to, close to 75, or, something like that, or 75, 76 CDDs. But I felt like something a little bit less than that was probably the right place to be in. I felt like it was very unlikely that we were going to break significantly from that pattern based on some of those factors. So that was my reasoning. Any questions? Um, Philip, would you like to go next?
Oh, okay, sure. So going into my forecast, I have a value of 63.9 and a sigma, a normal spread of 7.7. So this time my formula is largely the same. I did tweak things a little bit given the fact that it looks like the tropical signal is pretty weak. That was also cited by the CPC, and the teleconnections, which Michael will probably mention later, do not appear to be very, there doesn't appear to be a very clear signal from the teleconnections. The tropics, it does seem like right now that it's in the null phase and might head into phase two, but that's also not a very strong forecast. CPC is warm over the US again, except for the Pacific Northwest. The EC is also very warm, showing ridging over basically the entire CONUS, especially the northern half. And the CFS this time is also warm, showing a ridge in the northeast. So putting everything together and adding a 2 CDD fudge factor to account for the climate shift and the fact that everything, as you mentioned, is warm, I got my values.
Okay. So again, I'll start by playing devil's advocate here a little bit, or I'm the jerky uh, um, client. Um, so Philip, I'm gonna, frankly, I'm just gonna go with, I guess I'm biased here, but hey, Philip, I see that you're just slightly above the 10-year, but I'm looking at these forecasts from the EC Ensemble and stuff out in the 6, 10, 11 to 15, and they're showing, you know, 15, 20 CDDs above the 30-year, and you're just, you're a lot less than that. What are you? You're, 8 above the 30-year. Is that because you're being conservative, Philip, or is that i.e. it's 16 and 20 out, you can't be that precise, you can't be that sharp, or is it that you think the pattern is actually going to cool a little bit during that period, or do you just believe that the 6 to 15 is too hot?
I guess I would say it's a combination of the first one and the third one, more so the first one, where given how far out it is, I don't want to go too gung ho into everything since I've done that before and then seen my forecast fail spectacularly. And I guess the other thing is, since I didn't actually look at the 11 to 15 numbers, which I guess in the future I probably should, I also didn't have that as a reference, and I only had the 15 to 20 EC, which was I believe that was 66.78, or is it 67? And that was what I based it off from my EC signal. And it's sort of as a function of my other parameters, partly because I guess it's harder to translate them directly into CDD. So usually the numbers that I get from, say, the tropical signal and teleconnections are never that high. And that also plays negatively into that also prevents my number from getting as extreme as it potentially could be.
So, but just boil that down again, just in a like half sentence. Like, so the major factor was that it's so far out and you can't be that sharp. Is that right? You can't, you know.
Mm-hmm.
Okay, and then what was the other?
And then the other is that because the numbers that I get from some of the teleconnections or tropical signal are sort of subjective, so that usually ends up being a smaller number since it's hard to translate it into a very extreme number, and then that, as a function of my formula, usually means that my numbers end up not being that far from the climatological means.
Okay, okay, which would bring up a question then, potentially might ask you, like, Philip. So, uh, I guess a trader might want to know, is this about as warm as you could go? Like, Philip, what is the warmest you think you could ever be for forecast that's 16 to 20 days out? And the reason I want to know that, Philip, is because I understand you're telling me that let's, for example, you would never forecast a record warm pattern 1620. I get it. And maybe I even agree with your rationale. Maybe I don't, but let's just say for now I do, as the angry client. I get that you'll never forecast a record 1620. You don't think it's defensible. But can you tell me what the warmest, highest you think you will? Just because I want to calibrate. I want to know if this is about the warmest you would ever forecast. And if not, what would it take for you to get to that level?
This certainly comes pretty close. I would say for my warmest, that would probably translate into the fudge factor going up maybe another 2 or 3 CDDs. So certainly this is on the higher end of the forecast that I usually make, but it might take, I guess, maybe even higher confidence from the tropical and teleconnection signals that would push my numbers even higher.
Okay. All right. Fair enough. All right. Thank you, Philip. Any other questions for Philip? All right. Who would like to go next?
I can go next, unless anyone else wants to. Before I do, though, I just wanted to mention two interesting things. If you click on my link to the teleconnections, I think it's the if you look at the ensemble outlooks, yeah, they're broken on this page. So it's just kind of an interesting tidbit. If anyone wanted to see that. And sorry about that. I looked up last week, and I don't know if these numbers will coincide exactly, but I know for last week, our forecast, so the one verifying in about 10-ish days, the highest verification ever recorded on your climate sheet um, is 60. Maybe it was. This is no, the one after this forecast, the one we did last week. Yeah, this one I think. Yeah, yes. So the highest verification is 66.9. So if that lines up, if that 73 number happens and lines up reasonably with this, it'll blow the record out of the water by about 5 or 6 CDDs. So just thought that was interesting.
Yeah. Yeah. I'll pull it up while you're talking, but we can see. So
do you want me to just do my forecast? Because while you're pulling this up, it doesn't matter to me.
Sure. Might as well
Just
look at
save some
it.
time in case somebody wants to add something. All right, so my forecast this week was for 67.7 CDDs with an average spread of confidence spread of 7.7. So as I mentioned last week, I changed my formula to have a 10-year Euro blend as my baseline, and that number started me out with 63.7, which I adjusted down 1 CDD based off of mainly neutral teleconnection signals. They were, the signal strengths were kind of all over the place. Some were positive, some were negative. So to me, that screams a neutral signal. Then I raised it 5 CDDs based off the CPC forecast, which again had a huge bubble of warmth in the Northeast, over 60% chance of above normal temperatures. So cities like from the I-95 corridor from Boston down to DC, and so it was all in the above normal. The only area below normal was a small area of the Pac Northwest, which I think will be overridden by most of the above normal in, well, everywhere else. So that got me to my final value of 67.7. Any questions, complaints, comments, concerns?
Any questions for Michael? Let's see. I guess you might have a similar answer, but I guess, Mike, again, I'm with my client hat on. Uh, you've made the argument, about how this last week's forecast is going to come in, or is projected to come in at record levels. Um, you're forecasting certainly warm or anomalously warm, but you are not at record levels. Is that because you're it's again so far out, and you can't have that kind of precision? You have to be more conservative, or is it because you see something that suggests to you that the forecast is going to come off those record levels?
Well, it's kind of a two-part answer, or maybe three-part. But so I'll just go through with my thinking here. So part of the reason I don't forecast a record warmth this week, and I actually kind of did last week, it's essentially equal to the record. So I'm not afraid to forecast a record warmth if that's where the formula leads me. This week the formula did not lead me to record warmth. Um, The the other thing, I didn't see, as I mentioned, the formula. I didn't see any strong teleconnection signal, which I don't necessarily think it's particularly easy to get two record warm verifications in a row without some type of strong teleconnection signal somewhere. Doesn't have to be all four of them that I use, but I'd like to see one of them show me something. Um, and then finally, usually, and this might just be from my experience, but whenever there's a record event, usually you'll see a downturn. It's kind of hard to maintain record warmth or cold. Um, on a week by week basis. I could be wrong, but so that's my thinking as well. Partially that it's kind of hard to maintain. If we do end up having a record warm verification um, from the previous forecast, I have a hard time believing that we'll have two in a row. But it's not impossible, but that's just my personal belief on that.
Okay, so you're building in some synoptic noise. The other point, again, I'm with my client hat on. You alluded to the fact that certain teleconnection patterns, or at least this is how I interpret it, certain teleconnections might be are associated with better associated, whatever the word is, with record warm patterns. Which so what teleconnection pattern is associated with the record warmth? You said it's not there today, that a certain type of strong teleconnection. What is the type of teleconnection pattern that would be more strongly associated or correlated with the record warmth?
Well, what I said, or what I meant to say, was that I'd like to see one, not specifically one, but no specific one. I just would like to see one of the teleconnections show me a strong signal for warmth, um, for me to want to, or even be able, based on my formula, to forecast record warmth. It doesn't have to be any particular one. But if you want an example,
Yeah, but
if there was a super positive or a super negative um, NAO, like a -2 on and a pretty consistent -2, um, then that would be a strong warm signal if I have my seasons correct. um, Especially for I think the south and the northeast. Um, So again, bigger demand areas. So that would be something that I would need to see. The PNA could. I'm less familiar with its summer pattern off the top of my head, but the PNA would be one as well. The only one that I would say, to kind of reverse answer your question, that I would put a little less stock in would be if the AO was super negative or super positive, which is something I think rarely happens in the summer anyway. Um, I wouldn't put too much stock in that one just because the Arctic isn't too important in the summer. It's still important, but not as much so as it is in the winter.
Okay. Yeah, that's helpful. I would say you just, again, if you're, I, I, I guess a couple things. So one, that could be an interesting. So Lynn was talking about some interesting projects. I think this could be another interesting research study for anyone who's feeling ambitious. Um, what try to if you start by looking at just filter for, say, extreme warm. You could do this with extreme cold too, but top 10, top 5% of warm events. And then look at the association with different teleconnections to see, to test Michael's hypothesis. What's the what's the percentage of record of warm events that are associated with positive or negative NAO or this PNA or this or that, right? That would give more credibility, I think, to those kinds of things, and it would be a good piece of guidance. Just to give you an example, can you imagine? I'm sure this is not the case, but can you imagine if 100% of the warmest CDD patterns in the United States were all associated with negative NAO in July? Well, that would be helpful, right? If it's not a negative NAO, at least that might be a pretty good piece of evidence that you're not going to be in a record warm pattern, at least historically speaking. That's been the case. So, looking into some of that could be helpful. And I would just caution too. Now, if my client had on, I'm not sure. Like, I hear what you're saying, but think about this 11 to 15 day pattern that's coming up. That the gangbusters warm, the CDD pattern. It's not necessarily this which is projected to be record, right? I think this is the period. I think it's pretty much record. It's projected to be record warmth that this verifies, and the ridge is centered up across the upper Midwest. So although I agree that a ridge in the southeast, negative NAO kind of ridge, ridge Greenland, ridge over the southeast, is also typically probably warm. It may be that the record warm patterns are actually associated with this kind of pattern. So, just something to think about, especially if a trader or someone's going to ask you that question. Um, uh, I'm not. You want to be as clear as possible with the answer, and if you don't know, it's always good to say I don't know.
Yeah, I see what you're saying.
Yeah, just my 2 cents. I haven't, I'm not certain about that answer. Is all I'm saying. I'd be cautious if I was a jerky trader and you were telling me that, I might be like, hey, let me go see some of the data that suggests that, because blah 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 blah. All right.
Yeah, I probably could have just defended it by saying my formula didn't really give me the room this week to be record warmth, whereas last week it did.
Right. Right. Okay. What else? Let's go back. Who's Zach? Would you like to talk about your forecast?
He seems to have left.
Oh, we lost Zach. Okay. Um, anyone else hasn't gone yet? Let's see. Is this today's forecast? Matt's not here. They're not here. Sean. Oh, Sean. Sean, are you still?
Yeah, I'm still here.
Did you want to talk about your forecast?
Sure. It's a lot of echoing of what everybody else had. I would have went a lot higher with my forecast, but I tried to reel it back in based off of the neutral values for teleconnections, and then also ENSO is pretty close to neutral. A few months back, when NOAA put out their prediction for ENSO and sea surface anomalies, they had them entering a higher phase at this point. But they're not. It seems like it's going to stay in El Nino. And I saw at the JMA site that they have it predicted to be, El Nino, all the way through October. So it might be in a negative phase. So I think while the center of the country will see record-setting heats, the coast will remain relatively closer to normal. Plus anything over like 1.3 times the 30-year just seemed a little outrageous for me. So I tried to reel it back, but the EC and the GFS, CFS patterns looked exactly the same or very close. The CPC was forecasting below average precipitation across most of the country, and low soil moisture content would allow for more heating, especially across the central plains and the center of the country. And then I've been noticing a lot of weird readings from the MJOs. I've been checking different sites and comparing them. They usually it seems like it's sitting still, and then about like 2 weeks from now, it has it like racing off into phase 4 or 5. But even like with this map that you're showing right now, Dave, I was comparing this with the JMA one, and its verification for June 28th has it in phase 8. So I don't know what's going on with the actual location of it. Oh, is that it? No, that's what month is that?
Oh, is that the, yeah, that's got to be the pre. You're right. That can't be because it's 28, 29, 30, 31. So this must be, oh, wait a minute.
Right? Or is that 8?
Forecast? Or is this, this must, yeah, I think you're right. I
So
think,
it has a similar pattern. So with
yeah,
that green line for the next few weeks,
June is
um,
right there. June is right there. Where
yeah,
you see,
it
yeah.
actually has that a little bit above 0 in phase 8.
Okay.
But the pattern looks similar. It looks like it's going into phase 2. So that doesn't seem like there's any tropical forcing going on or anticipate to go on a few weeks from now. But then shortly after that, it has it rushing into phase 4 within a 5-day period, which kind of just seems odd. But again, that's a forecast. I don't really know how accurate that would be.
Okay. Any questions for Sean here in our last couple minutes? Time flew by. Well, I was just going to say, I know we're almost out of time, but I thought you brought up a lot of good points. Sean brought up soil moisture, which I don't think any of us touched on in a while, and I think that's a great point. Maybe we can take a look at that, some of those maps next week, because there's definitely folks in the community and research community who definitely emphasize. In fact, CPC I think includes it in their seasonal forecast projections, a month ahead. The belief that or the data that suggests that there's a significant kind of feedback mechanism. Once you get those dry soils or wet soils in parts of the country, that it could really feed back into the atmosphere and have an influence on temperature. So I thought that was a good point you brought up. And then the other point that I just want to say with the MJO was this was sort of I think similar to a point that Lynn was bringing up earlier, but every model is different, right? And they have different physics and initialization schemes. So you're right. You can see if you look, this is the ECMWF, but if you look at the GFS, et cetera, you may see that it's initialized differently, the initial day 0 spot. And of course, the forecast can be wildly different, or at least significantly different by day 15, right? Because, because by the time you get to day 15, there's so much potential noise and chaos there that you can have some differences. But these RMM projections are a function of, I'm not an expert in this, but 850 millibar winds, I think 200 millibar winds, and OLR. And I think mostly between like plus and minus like 30 degrees north or 15 straddling the equator. So, because the EC and GFS, again, have different information, observational information, and different initialization schemes, that even on day 0, they're going to have different wind measurements and whatever. So, the GFS could be over here, the Japanese model could be over here, and the EC over here. So there's obviously a lot that goes into that, and trying to understand which models are the best, and trying to maybe understand the systematic errors, et cetera. But I just thought that was a good observation you brought up, Sean. So, all right. I know we're out of time. I don't want to keep folks longer. Does anyone have any final thoughts on on today's forecast before we go? Well, I'll just say that it's going to be an interesting the next 2-3 weeks. We're definitely, it's going to be interesting one way or the other. I feel like well, I guess there's more than two directions, but either A, this reminds me of some of these recent summers where we're just going to go have some of these ballistically record kind of warm patterns, or B, this is going to be one of those situations that we've hit a number of times since the start of the forecast contest where it felt like nothing can go wrong. It's got to be warm, it's got to be hot, and then something goes wrong, and then we all look back and say, hey, is there anything we could have done differently? So I guess we'll find out, right, in the next 2 or 3 weeks. So, all right, well, thanks everyone for participating. And we'll, again, next week, we're doing it on Friday. And I think our start times on Friday are at 9:30. But just, check, we'll be sending out an email. So thank you, everyone. Bye.
Thanks. Bye.
Thank you.